Okay, let's take a look at 8.2, the distribution of sample proportions. I'm going to start with an example that explains what the distribution of sample proportions actually does. Let's suppose we want to know the proportion of all Jackson State students who own smartphones. So one thing we could do is we could survey the entire campus. And that's what we do right here. And remember, this gives us a parameter. So the population proportion, P, will be X, the number of individuals with the defined characteristic of owning a smartphone, divided by the total population. And you can see here that X, so let's assume 2,000 say yes, I do own a smartphone out of the 4,000, and that gives us a half. This is a percentage. Now, most likely we're not going to survey all 4,000 students, so let's assume that we take a sample, and the sample proportion we'll define as P hat, and we'll call it X over the sample size. And you can see here, out of the 100 students surveyed, 48 said, yes, I do own a smartphone, so we get this statistic. And the statistic matches up closely to what the true value is. Now our goal is to describe the distribution of the sample proportion P hat. Now, I want to pose a question. Let's assume 4,000 students are at Jackson State. How many possible samples of size n equals 100 can we take from 4,000 students? So that means what we do is we take the first sample consisting of 100 students. So for example, the first student might say, yes, I do own a smartphone. The second student might say no, all the way down to the 100th student. And they may say yes or no. So the question is, how many possible samples are there? So the question is, what is K? And K is equal to this big giant number here, which is really huge. Now, once we take the all the different possible samples of size 100, for each one, for this sample of size 100, we calculate the sample proportion P hat. For the first sample, the second, and all the way down to the last. And once we do this, we draw a histogram for all the possible P hats. And what we discover when we draw that is we discover that the distribution of P hat follows a normal distribution. And that's what we have here. Now, these are the results that we're going to use throughout 8.2. So P hat is a random variable. Just like X and just like X bar. It follows a normal distribution with the mean of all possible P hats equal to P, the population proportion, and the standard deviation for this random variable is given by the square root of P1 minus P over N. The z-score that we're going to use to convert is here. Okay, let's take a look at an example. Nationwide study indicated that 80% of college students with cell phones send and receive text messages with their phones. A simple random sample of n equals 200 college students with cell phones is obtained. Part A, describe the sampling distribution of P hat. Okay, so we assume that P is equal to 0.8. And of course, the sample size is n equals 200. Describe the sampling distribution. Now, there's two cases here that we have to verify, normality and independence. And the case for normality is just NP is greater than or equal to 10. So 200.8 for P. We get yes, this one's satisfied, and then N is less than 5%. of some big number n. This is the population would be all college students with cell phones. So this would be really big, and 200 is definitely less than 5%. So now let's get to the point we describe the sampling distribution. So to describe the sampling distribution, the only thing we have to do is plug in P, and then plug in P 1 minus P over N. And we do that, and we get the distribution P hat follows a normal with the mean here and the standard deviation here. So we're going to use the mean and the standard deviation here shortly. Part B, what is the probability that 154 or fewer college students in the sample send and receive text messages with their cell phone? So what this is saying is that out of the 200, what is the probability that 154 or fewer? Now remember, P hat is X over N. What we're saying here is the number of individuals X must be less than 154, which implies P hat will be less than X over N. So less than 154 over 200, or less than 77%. Now what we want to know is we want to know what's the probability that the percentage of students in the sample who send and receive text messages with their cell phone will be less than 77%. The percentage is less than. So the mean, we'll locate the mean, 0.8. 0.77 is our boundary point. And we want to shade in everything to the left. Now we have to convert P hat into Z. So Z equals P hat minus the mean over the standard deviation. So P hat minus 0.8 divided by sigma P hat. Remember, sigma P hat is here. So 0283 minus 1.06. So what happens is P hat's converted to Z. 0.77 becomes minus 1.06. And now we look this up, Z score here in table 5. Table 5. And when we do, we get 1446. What is the probability that 172 or more college students in the sample send and receive text messages with their cell phone? Is this result unusual? So X has to be more than 172, which implies that P hat is going to be greater than X over N. So 172 over 200. So P hat is greater than 0.86. So we want to know the probability that P hat is greater than 86%. And we'll have to convert P hat into Z. We'll label the mean, 0.8. We'll label our boundary point. And we'll shade in everything greater than 86%. And now we'll convert. So P hat minus the mean, P hat over sigma p hat 0.86 minus 0.8 over 0.0283, and we get 2.12. So this becomes 0, this is 2.12, and p hat becomes z. It's greater than 2.12. And remember, when we're finding the area to the right, whenever the arrow is pointing to the right, you can think about, we need to change that. So they change the sign of the inequality, change the sign of the number by symmetry. Now we look up minus 2.12 in table 5, and we get 0.17. Now I want you to take a moment and see if you can work through question 16. So what I'd like for you to do is pause the video and work through questions A, B, and C, and see if you get the right solution. So I'll give you a moment to work through this example. Okay, I hope that you had a chance to take a look. So the requirements, if you will check both requirements, normality is met, and also independence. And I'll just go ahead and let you know here that normality and independence will always be met for your homework and also for the exams. So you don't have to spend too much time checking these. Now the distribution, hopefully you were able to describe. P hat follows normal. The mean of all p hat is equal to p, the population proportion, which is 8.2, and the standard deviation is equal to the square root of p times 1 minus p divided by sample size n. Okay? Part B, what's the probability the proportion who are satisfied with the way things are going in their life exceeds 85%? So the mean is 82 from here. We'll locate our boundary point, 85, and exceeds will be this area. So what's the probability that the sample proportion p hat exceeds 85%? Now, we have to convert p hat into z. So let's go ahead and do that. So z equals minus mu p hat 0.85 0.0384, which is the standard deviation, which is what you should get from this value here. Once you calculate this square root here, then you'll get that value 0.0384. So So we get Z, and 0.85 becomes 0.78. All right, and remember, when the arrow is pointing to the right, we, by symmetry, can change the sign of the inequality and change the sign of the number. Now we just look up this value of minus 0.78 in table 5, and we get 2177. Would it be unusual for a survey of 100 Americans to reveal that 75 or fewer are satisfied with the way things are going in their life? Now, one thing you want to do here is double check to make sure the sample size has not changed. Okay, it was originally 100, so we got the distribution here based on 100, and so down here it's still the same, so we're still using that same distribution as above. Same mean and same standard deviation. Same mean and same standard deviation. Okay? So reveal that 75, so x is less than 75, 75 or fewer, implies that p hat is less than 75 over 100. So p hat less than 7. So saying 75 less than 75 out of 100 is the same thing as saying the percentage is less than 75%. So now we'll label our mean 0.82, label our boundary point 0.75, and we'll shade in everything to the left. And again, same old song here. We have to convert probability that p hat is less than 75. So you know at this point we have to convert p hat into z. So let's go down here and convert. P hat 0.75 minus mu p hat 0.82 over sigma p hat 0.0384. So we get minus 1.82. So minus 1.82. So this becomes 0. The axis becomes sort of a z-axis here. And the 0.75 becomes minus 1.82. All right, so now we just look this value up here in the table, minus 1.82, and we get 0.344. Okay, this is the end of 8.2. We'll continue to 9.1.